Okay, going over this information. I've just written the coordinates of the points, and that's it. And so I'm noticing like 2, 1. Okay, well, it seems like I see 3, 1 and 1, 3, except there's negative stuff in there. But I can see they trade places pretty clearly. So I could put the 1 here and the negative 3 here, but there's something a little wrong. So it was 2, negative 1, and then suddenly negative 1 is in the first place, but 2 became the opposite. Oh, it's 3, 1, and then 1 goes in the first place, and 3 became the opposite. So it seems like whichever one ends up in the second place ends up being opposite. So it's positive 3. And now let's go look and see if it actually looks right. So we're rotating 3. What's the point? The point is negative 3, 1. So negative 3, 1 would be right here, and we're rotating it 90 degrees clockwise, right? So 90 degrees clockwise would be like this, and so it would be perpendicular, and so right angle, and so it would end up here. So like 1, 3 looks like it, and that's right. So that was just me like double checking to make sure like the signs were right. You know, that was in the right quadrant even, right? Okay, so I can see what to do. Like, so when we have the coordinates of the point, we're supposed to switch them. So I can make it y comma x, except sorry, that was kind of funny. Except the second one becomes the opposite of what it was before. So the second one, you know, it was positive. 2 was positive, then it became negative. 3 was positive, then it became negative. Negative 3 was negative, but then it became positive. So that second one becomes the opposite. Remember, putting a negative sign there doesn't make it negative. It makes it the opposite of what it was before. And so that works for our pattern there. So you are not required to memorize that. You know, this formula that we see right here, it's not required to memorize. It's kind of handy because if you have that formula, then you can just take the points and just put them into the formula. And the book provides rules for each one. For 90 degrees counterclockwise, 180 degrees clockwise, 180 degrees either way, and then 270 degrees, again, counterclockwise because that's the default. One thing to watch out for, though, I left this off initially, and then I thought, ooh, I should put it. I thought, oh, what if I left off here? There's something where I haven't mentioned it yet. It's rotating around the origin. So remember, this is only if you're rotating around the origin does this work. That's what we were doing up above, and I promise you that that's what needs to happen. So you can have a figure like this, and it says rotate the figure to the right 90 degrees clockwise. So you can go, okay, 90 degrees clockwise. Clockwise is this way, yeah, so this is what I'm supposed to do. Oh, that's counterclockwise. So 90 degrees clockwise is 270 degrees. And so to use the chart, I'd have to do this one, not the 9 degrees one. Remember, the book defaults on counterclockwise if it doesn't say otherwise. So it says, okay, just switch the coordinates and make the second one opposite. So switch them and change the sign of the second one. Switch them and change the sign of the second one. And how about C? Okay, C is at 4, negative 1. So switch them and make the second one the opposite. And so now we can plot them. So now what I'm doing is I'm just going to plot these points just to make sure it looks right. You know, maybe I made a mistake. So A prime would be here. And you could see how that is 90 degrees clockwise around the origin. Cool. Just like, I'm just checking to make sure it works. Next one is B. 2, 3 becomes that. So B prime is 3, negative 2. This might look a little weird. Like this is where A prime, whoops, I'm sorry, not A prime. I was saying A prime, but A prime, B prime is this segment, and that's this segment right here. But if you think about it, like if you're pointing that way and then you rotated 90 degrees, you know, on this thing, and you rotated 90 degrees around this, then pivoting that, you'd end up down in the lower right-hand corner. It's still a little weird for me. Like it doesn't quite look 90 degrees to me in some ways. And that's just something that's not intuitive yet. And so I have to be really careful with it because it doesn't like automatically look, like I can't just look at it and go, oh, I can tell what it looks like. I have to kind of think about it a little bit. So if you're kind of struggling with the visuals on this, then that's the cool thing about the algebra is it makes it really, really clear what the answer is in a way that doesn't require me to understand it visually, like just intuitively kind of. All right, last one. C prime is negative 1, negative 4. So negative 1, negative 4. Cool, that's C prime. And there we go. Okay? And so this is the rotated triangle. just to show you this, I wasn't planning on this, but I'm going to be spontaneous. I actually drew this in GeoGebra right here. And so what I'm going to do is I'm going to do something a little funny here, and this is a spontaneous thing. And what I'm going to do is, I know, I'm crazy. What am I doing? And I'm going to make a little angle over here, and I'll explain why in a second. This is a thing to make GeoGebra do something spiffy. All right, and now I want to rotate this object. So first I'm going to make it a regular polygon, not a regular polygon. I'm going to make it a polygon, and I'm going to make it one big, whoops, cancel. I want polygon. There we go. And I'm going to make it one big polygon. Woo! And then back to the beginning. Yeah. So I'm just going to rotate this 90 degrees. Now I'll let you know it's not going to rotate everything. It won't rotate the vertices, but it'll rotate everything else. And let me put a point on the origin. Okay. And what I'm going to do, I'm going to change this angle first. So you get to see how I do GeoGebra, right? And what I'm doing is I'm showing you a visual of it so you can see that the thing we end up with is right. So what I'm going to do is I'm going to pick rotation here. Rotation. Oh, I'm a little off the screen. Sorry about that. You can kind of guess what I'm doing, but and it doesn't really matter because this is not a GeoGebra lesson. So I'm going to rotate this object, and I'm going to rotate it around this point, and that says, you know, how many degrees should I rotate it? Oh, wait. Let me see. I can't do it. I wanted to do it by a variable angle size. Shoot. Okay. There isn't a way to do this that I know right now. Rotate this object around this point. And yeah, and I can't do it. Oh, wait. There might be a way. That's all right. And it's 90 degrees. And we want to go clockwise. I'll just let it go. There you go. There it is down there. I was hoping to rotate it by this angle, and then I'd have a little controller. There's a way to do that. I'll have to figure it out. All right, enough rambling. So that's how you can rotate using a rule. So we have these rules for rotating specific number of degrees, but only around the origin. Okay? If you say, well, what about 100 degrees or 54.2 degrees? The rules don't help. You'd need something more than that. And so that must be something we don't worry about now. Finally, last thing for today's notes is rotational symmetry. So we saw line symmetry in 4.2 dealing with reflections. So what's rotational symmetry? An object has rotational symmetry if and only if it, come back. Back, there we go. It can be rotated some number of degrees, and technically I have to say less than 360 degrees. I mean, like, well, I'll finish the sentence, and look identical. I mean identical, completely identical. So, so if you like if you took this star and you rotate it 5 degrees, so it just goes like that, you'd say, well, it's still a star. Yes, but the picture doesn't look identical. It needs to be exactly back into the exact same position and orientation. So it still needs to have a point going straight up. So like I was saying earlier, the less than 360 degrees, like every object, if you rotate it 360 degrees, it looks exactly the same. So everything has rotational. Well, okay, so we mean something other than 360 or something less than 360. Okay? So you take a look at this object, at the first one, and you can rotate it a certain number of degrees, and it looks exactly the same. Now, this one, you might argue with me on this, because you might say, well, the bottom is shaded and the top isn't. Totally true. This object technically does not have rotational symmetry, because the only way to get it to look exactly like this again is to rotate it 360. But if you didn't worry about shading, then just the general object that you see, that does have rotational symmetry, and this one too. Okay, the angle of symmetry is the smallest angle you can rotate and have it look the same. Like, the idea on this is take a square. Like, You can rotate it 180. So yeah, it has 180 degrees rotational symmetry, but you can rotate less than that. So we'd actually say this thing has 90 degree rotational symmetry. That would be the angle of rotation or the angle of the symmetry. If, people say, yeah, it also has 180 degrees. But when we say, well, what kind of symmetry does that have? We focus on the smallest angle that you can find. So, example, what kind of rotational symmetry do these figures have? So they all have rotational symmetry, with this one with a little asterisk next to it. And the question is, how many degrees can you rotate it and have it look the same? So if you're kind of wondering about this, or how would I do the star thing? Well, think about it this way. If I kind of draw it like this, I think you can see how I could divide it up into like 5 sections there. And I could rotate one of these things and it could go and become here. So like if this point was A and I made this A prime right at the end there, then it would look exactly the same, and every other point would move around also. So I just need to figure out how big that angle is. Some people are maybe figuring it out. And you go, well, all the way around it's 360, and every single one of these are the same, and there's 5 of them. So that means it must be 360 over 5, which is 72 degree rotational symmetry. Okay? How about the next one? How many degrees can you rotate it and it looks the same? Ignore the shading. Okay, the correct answer here is 180. If you said 90, you need to think about the fact that this thing's tall. So if you rotate it, it's tall here. So if you rotate it only 90 degrees, then it's going to be kind of wide. It's not going to look exactly the same. It's going to look different then. So you have to get it all the way around for it to be the same, because it's tall and it's not, totally symmetric in that sense. And so therefore this one would be 180 degrees rotational symmetry, because like this point would have to be rotated all the way down there and be 180 degrees. If you rotate it 90, yeah, it's the same object, but it doesn't look exactly the same with the ignore shading comment. It would look different. It'd be a wide figure instead of a tall figure. So that would look different. Last one, you have enough information to figure this out on your own if you want to. You could do the same thing as the first one. You say, all right, so I got this, I got this, and I got this, and I want to rotate it one of those. Remember, you can rotate it 2 of them, but we give the smallest angle for the angle of symmetry, for the basic angle of symmetry here. And so this would be 360 divided by 3, which is 120. If you said 60 degrees instead, some people say 60, they kind of go 360, and I don't know, they say that. I totally get it though. And what it is you have to realize that if you only rotate it at 60 degrees, then this peak right here would be going this way instead. 60. A little less than 90 degrees. You can see that that's a little less than 90. And so then it would have like 2 that were sticking up like this and 1 that was sticking straight down. And it wouldn't look exactly the same. Okay, so the goals of today were remembering for the 2 videos, learn how to perform and identify rotations. And we're focusing on 90s and 180s and 270s. We're focusing on those ones because they're the easiest to draw. In the normal class, we'd use a protractor and do other angles, but that's kind of like that's a COVID casualty there. And so, woohoo, you don't have to do something. And then we learned how to have a rule for rotation, and that there's some rotation rules that are just given that I can just tell you, here's the rule, and you can find them in the book. And that's kind of handy. If you don't know them, you could do it by hand. But if you know the rule, then it's really fast to rotate stuff because you can just plug the numbers into the formula. And then finally, we've got rotational symmetry, which is, what does it mean to have rotational symmetry? And then how do you identify how many degrees the symmetry is? And I kind of showed you a couple of examples where you could see that. Make sure that you've filled out your reflection so we can see how things are going, and that's it. So hope you have a great day, whatever day you're doing this, and we'll see you for this homework. This homework is due on Monday, the 23rd. So we'll see you then for more things about rotations. Bye-bye.